Hello everyone, welcome back. So this is chapter 2. Okay, so let's start on chapter 2. So for this lesson we will learn on how to do the convolution sums using graphical method. Okay, so at the end of this topic, student will be able to solve the convolution sum using graphical method. Okay, previously we already learned on how to do the convolution sums using analytical method. So convolution sum, the formula, let's recap back. Yk equals to hk convolution with xk convolution with hk, equivalent from the summation n equals to minus infinity to infinity x of n hk minus n equals to summation of n from minus infinity to infinity x k minus n multiplied with hn. Okay, for this lesson, let's look at one example. So the examples mention that illustrate the convolution of yk via graphical method for xk 0, 2, 1 and hk equals to minus 2, minus 1, 0. So this xk is actually the input and input response, and hk is impulse response. So this question asks to find the yk via graphical method using these two responses. So the underline here is actually the origin of x0, and hk here, this is the origin of h0. So what does it mean by is that when you plot the graph of xk, so the origin here is 0 at the value of 0. So x1 is 2 and x2 is 1. Okay, and also for hk, same goes for hk. So the origin is actually started here. That means at h0 is 0. So this should be at h minus 1 and h minus 2, which is the value is minus 1 and minus 2 respectively. So the solution, if we refer back to the original equation, yk is xk convolution with hk. So first of all, you have to draw both the input signal of xk and hk. Okay, so the origin is the value at 0 is 0, and then the value at 1 is 2, the value at 2 is 1. So k. So this is the x-axis and y-axis. And for hk, it's at 0, minus 1 and minus 2. So this is the value for both. Alright? So this, based on the equation, we know that yk is equals to xk convolution with hk, which is xk times h n minus k. So we use this. Okay? From n equals to 0 till maybe 2, for example. So shift hk to h minus k. So first of all, you have to shift the original hk. Okay, this is the original of hk. You shift to h minus k. So what is actually h minus k? This is actually the mirror image of hk. Okay, mirror image of hk if you shift it vertically. So that means you shift it vertically. So it's here you say it's 0, minus 2, minus 1 and minus 2. Okay, if you shift it vertically, okay, this is your axis. So it's become 0, 1, 2. Okay, so this is h minus k. So we're going to use this because from this equation is h minus k, n minus k. Alright, so let's say n k xk has to be remain the same for all values of n. Okay, let's n equals to 0. Then hn minus k will be n0. So it becomes h minus k. Right? 0 minus k, so h minus k. So y0 is xk multiplied with h minus k. Right? So this is the xk, and it's multiplied with h minus k. So how are we going to solve this? So we have to draw a table for easier method. So draw a table. So this table consists of xk, h minus k, and y0. Right? So you have to plot. So this is h minus k. So xk at minus 2. Okay, we start at minus 2 because previously hk start at minus 2. So this is the x-axis. So minus 2, minus 1, 0, 1, and 2. So xk minus 2 is, what is the value? 0, right? So just put 0 here, 0. At 0 is 0. At 1, what is the value? Is 2. And at 2, the value is 1. Right? So 0, 0, 0, 2, 1. Okay, then tabulate the data for h minus k. So at minus 2 and minus 1 should be 0, 0. At 0 also 0. At 1 the value is minus 1. At 2 the value is minus 2. Okay, correct? And then you need to find what is y0. So y0 is the multiply of xk times with h minus k. Alright, so that means 0 times 0 is 0. Okay, and then solve for everything. 0 times 0 is 0, 0 times 0 is 0, 2 times minus 1 is minus 2, 1 times minus 2 is minus 2. Okay, so you already complete the table. Alright, so now, therefore, how to find y0? So y0 is the summation for all of this. So 0 plus 0 plus 0 plus minus 2 plus minus 2 become minus 4. So y0 is minus 4. At n equals to 0, y0 is minus 4. Okay, now let's n equals to 1. So when n equals to 1, the hk have to move to the right by 1. Okay, hk move to the right by 1. It becomes h1 minus k, because now n is 1. Remember, n minus k, so 1 minus k. So based on the h minus k graph, you move to the right. So just now you start at the 0, start at 0, right? So you move to the right, it becomes start at 1, at 2 is minus 1, at 3 is minus 2. So this is h1 minus k. And then same step, you have to draw a table. But remember that xk has to be remain the same. Xk remains the same value. Okay. So you have to draw a table. So remember, just refer back to the original xk graph. So minus 2, it should be 0, 0, 0, 2, 1, 0. Okay, why I put another extra 3 here? Because h1 minus k, it's up to 3. Okay, so this is the x-axis. Okay, so xk is the same value. So h1 minus k, you have to shift to the right. So at 2 is minus 1 and at 3 is minus 2. Okay, remember that to find y1 is the multiply of x, k, and h1 minus k. Okay, so 0 times 0 is 0, 0 times 0 is 0, 0 times 0 is 0, 2 times 0 is 0, 1 times minus 1 is minus 1, and 0 times minus 2 is 0. Okay, so this is the table, the complete table. So now y1, remember, is a summation for this number. So you have to plus everything. So what is the answer? y1 equals to minus 1. Okay, for n equals to 1, y1 is minus 1. Okay, now let's n equals to 2. Say then h minus k move to the right by 2 becomes h2 minus k, because n equals to 2, so h2 minus k. So you have to shift by 2, the hk, alright? Hk move to the right by 2. So this is the graph for H2 minus K. Okay, so 0, 1, 2 is 0. So it starts at 3 minus 1 and 4 minus 2. So same procedure, draw a table. So xk remains the same. So this is the value of xk. So axis, since it stopped at 4, so I add in 4. And then I didn't put minus 2 and minus 1 here because we know that it's already 0. Okay, so H2 minus K. So at 0 is 0, at 1 is 0, at 2 is 0, at 3 is minus 1, at 4 is minus 2. Okay, so y2 is the multiplication. Yes, correct. So you multiply. When you complete the table, y2 is 0. So you sum up everything. Y2 is 0. For n equals to 2. Okay. You don't have to use for n equals to 3 because the answer will be 0 as well. So let's n equals to minus 1. Then, okay, now n equals to minus 1. Okay, previously is plus 1. So this one is minus 1. So what happened to HK? H minus K? H minus K have to move to the left by 1. So it becomes H minus 1 minus K. So this is the graph for H minus 1 minus K. Shift to the left. So that means it's minus 1, 0, and 1. So at 0 is minus 1, at 1 is minus 2. So same procedure, draw a table. Xk is the same value. So we start at minus 2 here, okay? Because, minus 1, minus 2, minus 1, 0, 1, 2. So this is the x-axis. So H1 minus 1 minus K, at 0 is minus 1, at 1 is minus 2. Okay, so H minus 1 you multiply. So 2 times minus 2 is minus 4. Alright, so what is the value of y minus 1? Summation of everything. So y minus 1 equals to minus 4. So for n equals to minus 1, y minus 1 is minus 4. Okay, now let's n equals to minus 2. Okay, when n equals to minus 2, it has to move to the left by 2. So it becomes h minus 2 minus k. Okay, so this is the graph of h minus 2 minus k. So you have to draw a table. So now h minus 2 minus k is that it's minus 1. It has value here, minus 1, and 0 is minus 2. And then you have to complete the table. So when you multiply, you will get y minus 2 equals to 0. So n minus 2, y minus 2 equals to 0. Okay, so you don't have to do n minus 3 because you will get 0 as well. So finally, after you get all the data of n0, n1, n2, n minus 1, and n minus 2, you have to draw the final graph of yk. So the final graph, so this is the final graph of yk. So at 0, remember, y is minus 4, at minus y is minus 4, at minus 2 is 0, at 1 is minus 1, and at 2 is 0. And then you have to write the whole equation here. Yk equals to 0, minus 4, minus 4, minus 1, and 0. And remember that this is the origin of y0. Remember to always bold and underline this origin so that we know that this is the origin of the y0. Alright, so that's all. You already complete the exercise. Okay, so thank you for that. Hope to see you again for the next lesson. Bye.